Welcome guys, so I'm Thomas and I'm going to talk a little bit about what I call responsible developer. And you wonder what that is. I do as well. I'm not really sure about all the details, but I'm pretty sure what I don't think is responsible behavior. So we'll see where we end up. A developer, that could be seen as a device that turns coffee into code. So I asked a friend of mine, what do you think is a responsible developer? And he suggested coffee and pizza. Combined them and we got code. Yeah, I can understand how he's thinking. I'm not convinced that that's correct though, but I understand how he's thinking. Sometimes. He's also a tester, so I don't understand all the time when he's thinking, because testers has a different mindset than developers sometimes. Anyhow, another suggestion could be a superhero, like this guy, or for that matter, a firefighter, a guy always fixing all the problems. But the problem with the firefighters is that it happens that they actually create the fires, so they have something to fix. So I don't think that Superman, or for that matter, firefighter, is a responsible developer. This, however, is a guy that I know that I would describe as a responsible developer. He's a pretty ordinary person. This is Alex from Romania. He lives in Bucharest. And I shouldn't even try to pronounce his last name, unfortunately. He's a great guy, he's quite ordinary, and he has a passion for programming, and he wants to do a great job. So this is one example of a responsible developer. And anyone interested could try to follow that link that will be available on these slides afterwards to see what he thinks, or understand how he's thinking about development and being responsible. Or in this case, the craftsman he would like to be. So it's a lot about the mindset, being responsible. And in that sense, you must like and embrace changes, because changes happens all the time. So if you don't like changes, well, then you will have a problem. And a responsible developer will probably embrace and like changes. It's someone who understands that it's not a utopia to divide a problem into smaller parts, which I have heard from a developer that I used to work with, that this is impossible. I wouldn't describe that person as responsible, and I know that you can divide problems. You might not want to divide them, but you can divide them. So it's a responsible developer will always try to divide a problem into two parts, because it's a lot easier to solve a small problem than a large problem. Another developer at the same project actually said once that he would never ever write a program unless he was paid for it. That's not responsible. So a responsible developer will do programming even if he or she isn't paid. A little bit more than 10 years ago, a bunch of guys met in the US somewhere at ski resort, and they came up with something called the Manifesto for Agile Software Development, where they talk a lot about individuals and interactions, working software, customer collaboration, and responding to change. This is a good start. And what they are talking about is, in many senses, communication. So this is key to a responsible developer, communicating with other developers, customers, well, anyone that you need to communicate with. And when you do that, you make sure that you use the language of the customer, so the customer actually understands what you're saying. Your average customer doesn't know anything about for loops, while loops, hash tables. They don't care either. So the language we use as developers, nope, don't do it. Use the language of the customer. Try to express the problems the way they would express them. And that's difficult. But that's one way of communicating. Behind the Agile Manifesto, there are 12 different principles. One of them are my absolute favorite: continuous attention to technical excellence and good design enhance agility. This is great because now I have something I can point to when I want to be a geek and really focus on something and be really good at it. So technical excellence, that's something. Simplicity, the art of maximizing the amount of work not done. Well, that's really, really difficult, and that's also something nice. So these two combined, well, that could give you some leads to what a responsible developer probably is. A long time ago, Kent Beck wrote a really good book called XP Explained, I think it's called that. Anyhow, he defines these 4 rules of simple design. And I would say that if you're a responsible developer, then you might not know about these rules, but you will understand how they work. And they are really important, and they are important in the order they stand here. So tests should pass. All tests should always pass. That's a good start. It also means that we have tests, and we're able to run them. Perfect. We should always try to express the intent with the code we write. So communication, again. Communicating with your future you or fellow developers. Writing really clear and easy to understand code. We will try to avoid duplication as much as we can. But if we have to choose from expressing ourselves properly and duplication, we will prefer to be expressive, and in that case, accept duplication. And we will always try to do whatever we are doing as small as possible. That means small classes, small methods, whatever small happens to mean. So try not to build something really large. That's the message. How do you build a system? There are different ways of doing this, obviously. It's really easy to say that you do it incrementally. You build a piece, and then you add it. And then build another piece, and then you add it. That's pretty much as paint by number. You fill in these different fields with different colors, and all of a sudden you have a really nice painting, or at least a painting. It might be nice. This is really easy to think that this is the way to do it. And you know, it's not. Because someone has to come up with this plan. And that's not easy. You could think that you would have some kind of dream of how it should be at the end. Fix small parts of it and do it perfectly. No, sorry. This is not the way you do it if you're responsible. This is the way you do it if you do waterfall. And that's not being responsible. It's a lot better to do it iterative. You build something, and you evaluate it. You build a little bit more, and then you change it a bit, perhaps, and re-evaluate it. So small things, but all over the place. You have an idea, you create a sketch, you enhance the sketch a little bit, and you enhance it even further. That's the way to build a system. And these images is published by Jeff Patton, and I don't really know when, but I think it was a long time ago. So, we try to divide things, and then we conquer them. Have anyone thought about the Unix way, and how the things are built in Unix? They solve one problem, and then you can combine them. So in this case, if I want to count the number of files in a directory, I use 2 commands and then connect them with the pipe. So I list all the files and then I count them. 2 relatively easy or simple operations, and then you combine these 2 parts into something bigger. This is an example of really small things or small tasks. And therefore, if we have small tasks, we can have really small solutions. So dividing stuff and then conquering. And this is definitely the better way to future-proof a system. Can anyone guess in here when Unix was first launched? Does anyone know that? Sorry? 1970. Yeah, it's on the slide, but let's see. We can know that it has been around for a long time. And this image, which I found on Wikipedia, claims that it turned out 1969. So 1970, really good guess. How many in here was born before this? Oh, I'm the only one? Okay. So you guys are all younger than Unix. And it's built by really small pieces. Think about that, if you want. Okay, so how do we build a system? Well, I like the idea of walking skeletons, where we hook up whatever we need. It may not be perfect, and all the bits and pieces that we need aren't available yet, but we create a skeleton that actually, in a sense, somehow almost works. It doesn't solve all the problems, but it solves enough so we can understand how we should enhance it to actually get something that actually works. So we start out with a skeleton, we add a muscle here, add a muscle there, and after a while, we might be done. So we try to work in vertical slices, that is, slicing the system in that way instead of slicing it or layering it in that way. Something like this. We have a user interface, real users, you know, guys typing, clicking, real users. We have some kind of database, probably. Not all systems have databases, but many have. And then we build it using pipes, like this, one slice at a time. The first implementation will probably just solve a small problem, but it will solve the entire problem, or at least enough of it. And then we'll take the next one, and then the next one. And if we're lucky, then we might be able to finish it. Otherwise, it might be good enough, and we might just stop. But if we stop at the point when it actually works, then our users could be happy with it. I don't know if you've seen this image. It has been floating around on Twitter lately. This is one way of building a minimum viable product. That is, a product that we can use and perhaps not be very happy about, but it would work. But if we start out with fixing a steering wheel, a couple of wheels, add a body, and then deliver a car, no one will be able to use this until the fourth iteration or fourth delivery. No one will be happy when they have a steering wheel, unless you're a little kid and like steering wheels anyway. But any real user will not be happy if it is a vehicle they actually want. They want to transport something.
Did you try to make a car from skateboard?
No, I have not tried to do that. But if the problem that we should solve is perhaps moving... let's take a real problem. On Friday, I was preparing for a party with an orchestra I'm playing with. We had to move a large crate with a bar in it, lots of bottles, really heavy. We had something very similar to skateboard that we could place it on and then push it. We were quite happy because we're not that strong and we couldn't lift it. So it solved the transportation problem. We could have been happier if we would have had a car to solve it, but it was good enough in this case with a skateboard. So if it's just a transportation problem, skateboard could be enough, or this bicycle that kids has could be enough. The best solution could be a car, but maybe we can't afford building a car. And the only thing we need to solve is moving this box with a bar. We don't need a car for that. Simple code is better than smart code. What do I mean by that? Well, I mean that a responsible developer knows that it's a lot better to write some code that is simple to understand than to write something that is really smart. Because if it's really smart, and it's hard to write and it's hard to understand, therefore it's hard to maintain. So simple. Simple is better than smart. You know this expression, KISS, keep it simple, stupid? There's a reason for it. So we would prefer to have simple code on smart data or data structures instead of smart code on simple data. Sometimes the best solution could be a hash table, which is in a sense pretty smart compared to, say, I don't know, a linked list or something. And in other situations, a linked list is the best option. So store it in a good data structure that actually supports the problem that you are working with, and make sure that the code manipulating this one is easy to understand and really, really simple. A responsible developer knows that sharing and learning, that's very, very important. And how can you learn the best way? What is the best way to learn stuff? Well, when we talk about programming, I think that pair programming is among the best ways to do this. My experience as a teacher at the Technical University tells me that whenever students solve problems in pairs, it was a lot better compared to when they solved them themselves. And pairs were always better than triplets. And groups of 4, they never actually solved the problem in a good way, so everyone understood it. So pair programming, that's a great way to learn from your peers. This also emphasizes shared code ownership. Because if 2 people are working on the same piece of code, who is owning it? Whose responsibility is it? Hard to say, it's both. So therefore, we emphasize sharing the code ownership. Another way of sharing and learning is mentoring. Mentoring other developers. And the reason for this is that you must understand whatever you're talking about before you can explain it. And sometimes that's not correct. Anyone ever heard about the concept of a rubber duck? Yeah, someone? Okay. But not everyone. Okay, so rubber duck, that's something introduced in the book Pragmatic Programmer, and it's older than that, but anyhow, what it's all about is someone or something that you explain your problem for. I suppose that everyone has had a problem that you couldn't really solve. And then you went to a colleague and asked them if they could help you. And you tried to explain the problem for them. And while doing this, you understood, or you got a new angle of it, so you could work more on it and solve the problem. Your colleague probably didn't understand anything, but that's okay. Your colleague was just a rubber duck in this case. So someone that you explain something for, that's a rubber duck, and when you do that, you sometimes find a solution yourself. Otherwise, you must understand it before you can explain it, and that's the reason why it's so really beneficial to teach. Because teaching means constantly learning, and that is a win-win situation. You learn as long as you have students. And that's one of the reasons why I'm a little bit sad that I'm not working as a teacher anymore. But yeah, you learn as long as you have students. And students, they hopefully learn something as well. So it's a win-win situation. A responsible developer wants to know that it works all the time. This means that we are constantly testing. And that doesn't really scale if we do it manually. So we have to write code that actually tests code. So how many in here are writing code that tests other code? Oh, the rest of you have something to learn. It's fun, it scales, and yeah, as Steve Freeman said recently, it may be one of the most important things that has happened within computer science for the last 10 years, and that's test-driven development. But this is a lot older than 10 years, so it is possible to trace code that tests other code back to the 50s, if we really want to. I know that I did it 97 the first time I did it, And a friend of mine asked, "Are you stupid? Why are you writing code that is testing the other code?" It was fun. It felt good. I didn't need more reason than that, but yeah. So I've done it before Kent Beck wrote the book and rediscovered test-driven development. So this leads me to write test code first, and therefore test-driven development. If you haven't done it, try it. It's fun. It's very fun. I say that this can keep the code clean. And what do I mean by that? Well, I mean that if you have developed code using test first, then you have something, you have a safety net that will save you when you change the code so it's cleaner, but still want to know that it works. So you can do refactoring on this piece of code without being afraid. And clean code is really, really important because code is written once or twice perhaps, but it's read very, very often. And it's maintained during a very, very long time probably. So writing code that is easy to read, that's very, very important. Readability simplifies maintenance. So I had a discussion with a friend late Saturday. We had been drinking, so I'm not sure if it was a clever thing to discuss, but we did that anyway. And he claimed that one of the things he spent most time on working as a developer is to write code so it's easy to understand. And I can understand that, because it's really, really hard to write stuff so anyone else can understand it. Or for that matter, yourself in 6 months. Have you ever experienced that you have to go back to something, you can't really understand what it is, and then you check the source control and realize that, hey, I wrote this crap. I have. That's not fun, and it happens. When we write code that tests other code, test code, then it's really important that tests are the most cleanest part of it, because if we can understand them, that means that we can understand what the system should do and what we actually verify that it does. I don't say that the tests are right or correct or anything, but we're able to understand at least what we are trying to verify or validate. And this is a comment that Åslak Helsey delivered on a web, not a web, but a mailing list, pretty much 3 years ago. Where he discussed someone had written something really, really clumsy in Cucumber, and he claimed that clarity always trumps dry, and definitely in a test. And I agree, because if it's clear, then I can live with duplication. Duplication is bad. Stuff that can't be understood is worse. So clarity always trumps dry. And the good thing with code that tests code is that we can use these as automated acceptance criteria. If the system compiles, well, that's obviously good, but if the system compiles and all the test passes, and the tests are good, then we can ship it. Doesn't have to be like that. It happens that people do manual testing anyway, but the goal with the testing should be that the testers, if we have specific testers, should have the most boring job in the world. They should never find anything. And when they find something, make sure that we have an automated test that prevents us from recreating this bug again. If we do it this way, then it's very beneficial to write the testing outside in. Why? Well, this means that if we haven't implemented anything, and we do it just by looking at the expected or wanted behavior of the system, then we can avoid testing implementation details. And why is that important? Well, we don't want to tie our system to a specific implementation. We want to tie it to a specific behavior. And this allows us to focus on some high level of the problem and don't get lost among all the details. We'll probably get lost anyway, but we don't have to start there, being lost, because it's not that good. This is one way that you can express a wanted behavior in a system. This is something called Gherkin, and it's a language that I will have a tutorial about tomorrow when I will be talking about behavior-driven development and Cucumber for Java. Believe it or not, but this is possible to execute. I can run this, and I can change it and see that the system doesn't pass. But this is possible to translate into something that we can execute. And if you're interested, show up at my tutorial tomorrow, where I will talk about this a lot. But this will enable you to always keep an eye on the overall picture and not focus on the details. We're really good at focusing on details as developers. And that's important. Details are important, but not that important, not always. And it's not the only thing that is important. The system should work as well. So back to clean code. Has anyone heard about the Boy Scout rule that Uncle Bob, Robert C. Martin, is trying to sell? Do we have any scouts here? No scouts? Yeah, 1, 2, perhaps, okay. So, you being a scout, you know that you should always leave the campground in a better shape than you found it. Or so I've heard at least. I'm not a scout myself, but if we do the same thing with code, then we will end up with something that is better than it was a few minutes ago. And after a while, it might actually be really nice. So if we apply this, the Boy Scout rule, in our daily job all the time, then we will build stuff that are a lot nicer and better than they used to be. So think about this one here. This leads me to refactoring, because cleaning code means refactoring. And the question is, what does refactoring actually mean? Some people say that it means improving the code. And I say, no, it does not mean improving the code. It does not only mean improving the code. It actually means improving the code while maintaining the functionality. That's a difference. So, this is refactoring, and we can't be sure that whatever we changed didn't change the functionality unless we have tests that actually saves us when we make mistakes. It doesn't work like that. This means that there will never ever be a need for large rewrite. I've heard about teams that has or plans to have sprints, that is refactoring sprints, or I don't know, hardening periods after all the functionality is done. Then they spend a couple of sprints just, I don't know, making sure that the stuff doesn't break. In my book, that's just stupid. Refactoring should be done in small steps, and you should always maintain the functionality. And you should never, ever ask for permission of doing refactoring. Never. Because the guy you're asking, he might or she might not understand the value. Just do it. Just do it under the radar. But don't spend the entire day with it. Spend a couple of minutes. They can't tell the difference. So don't ask for permission, beg for forgiveness if you end up in problems. A responsible developer will always try to deliver value. That's actually why we have a job. Because if we don't deliver value, then someone else could do whatever crap we're doing. So we always try to deliver value. And that means that we have to deploy very, very often. because that's the only way I know that we can deliver value to the customers. If a customer can't use it, then there's no value with it. I saw a couple of guys outside that had this T-shirt, if it isn't delivered, it's null. I'm going to try to get one of those T-shirts because it's a great quote. So let's try to deliver some stuff to our customers. Otherwise, they can't use it, and it's just waste. And therefore, if we can't deliver something that works properly or is perfect, deliver prototype instead. It's worth 1,000 words, at least. This means that we have to build the system often, after each commit, preferably. And this leads me to continuous integration. How many in here are doing continuous integration? Okay, well that's better. Add some test-driven development on top of that, and you might do something really good. Continuous integration. Building as soon as we check in something. There are a few things that you have to think about. You always have to keep the build green. Otherwise, well, it won't be green. So we have to fix broken builds immediately. You might end up with something like this otherwise. This is something called this is building in St. Petersburg, I think it is at least. Fixing the windows here could take forever. But if they had fixed the first broken window, then it might have been easy to fix the next broken window. So fix the build immediately. Don't allow it to take hours before it's green again. And by the way, commit and run. Highly illegal. Don't do it. If you can't do a commit and then wait for build, don't commit. Commit tomorrow. That's a lot better. Because if you do a commit and then you run, you would probably break something and you will create a mess for your fellow developers. Don't. We would like to have something that is deployable from the continuous integration. And therefore, we always have to keep the code in deployable state. That's not that easy, is it? There is one trick that is actually working very well, and that's feature switches. So you can hide stuff that isn't ready yet. Suppose that you're implementing, I don't know, search functionality in a website, to take a random example from a project where I'm working, but it doesn't really work yet. Make sure that the end users can't use it. Just hide the widgets on the website if you can't hide it in somewhere, some other way. But make sure that you can turn it on and off easy. So you can turn it on in test environments, for example, and perhaps turn it on in a production and then turn it off if it didn't work properly. So feature switches. This is a way to hide stuff that isn't done yet, and you can always keep the project in deployable state. Deploy often. As I said, that's the only way to make sure that people get something to use and therefore get value. But when should you deploy? Well, to start with, never before you go home. Because you have probably something better to do than stay and fix the production issues you just created. Perhaps you have a family that you want to take care of instead. Okay, so not before you go home. Before lunch, that's a lot better. Perhaps on Monday, because then you have the entire working week to fix whatever you broke. That's a lot better than doing it at 5 o'clock on a Friday. You don't do that. You don't do it on Fridays at all. Deploying often means deploying small things. And that's really good, because it's really scary to deploy large things. It's really, really scary. I hate it. I hate the feeling of not knowing, will this break or not? And if it breaks, I know that I will probably spend the weekend or more than that fixing it. I don't like that. Because I'm not a hero, and the responsible developer is not a hero. He or she is not even brave. We don't take risks, we play it safe as possible. So deploying often, what does that mean? Or what does that imply? That implies How should we do it? Yeah. How should we deploy often? Well, there is only one answer to that question, and it's automated. And how we automate stuff, that's different from project to project. So I can't tell you about the details here. But I can tell you that the value of automating the deployment is huge. And you can be lazy, and laziness wins in the end. A quote that I translate from Swedish. Victor here. The same guy who spent a lot of time writing code that is clean. He's also a bass player and a really good arranger. He claimed that he's lazy, so therefore he tries to do things one time. And automating things is a great way to do that. He also makes sure that he writes out a date when he wrote an arrangement, so everyone in the orchestra can know that we have the same version, because it happens that he delivers more than one version. So laziness wins in the end. And manual deployment is, among other things, boring, error-prone, and therefore stupid. If you do that, stop. There's something that you can automate. Do that. Another thing that is really important is that whatever system we're building is easy to operate. The operations guys, they are not our enemy. They are our friends. So make sure that it's simple to deploy. Make sure that you're perhaps rereading new properties if a property file is changed. Make sure that logging is good, so we can understand what's happening. You don't want them to wake us up in the middle of the night. The same thing with our users. Don't scare them with bad error messages. We don't like things like this. Someone is using something, some kind of error, we'll probably die everyone. Don't do that. This is better. We made some mistake here. And the user will be able to understand that whatever he or she did wasn't they who broke anything. They're not responsible. So don't scare people. A responsible developer is constantly learning. And what are we learning? Not yet. This is obviously really bad news if you don't like learning new stuff. I hope that attending a conference like this is a way for you to learn new stuff, so you're not part of that category. But what are we learning then? Well, there are always new techniques, new tooling, and new things that the customer or users want us to implement. What about the tooling part here? Well, a responsible developer knows that there are a lot of sexy tools and framework out there, but also that they will probably not solve the problem enough. So we're not fooled by that. You still need to think for yourself. Sorry. But at the same time, make sure that you always use the best tools available that you currently know of. These tools are great for some jobs. And remember that poor craftsman blames the tools. A worse craftsman doesn't even know how shitty his tools are. So don't ever use a wrench. That's illegal. And I can say that because I've been working as an aircraft mechanic. I did have a wrench, I never used it. So we learn about domain knowledge. And this means that we can always divide and conquer given the new knowledge that we have learned from the domain. And this, unfortunately, sometimes means that we get new knowledge and we do it again and realize that, the solution we had wasn't great. But we probably learned something from it. Guesstimates. People usually wonders, when are you done? Are you done? But the best we can deliver is guesses. So let's call them what they are. They are guesstimates and nothing else. And we know that it's really hard to guess, and we always guess wrong. You tend to underestimate the complexity of the problem, always. And you overestimate your own capability. Sorry guys, we're not that good as we think we are. could be something like this. I mean, this looks very simple, doesn't it? But behind this wall, there's something that will probably stop us for a long time. This is reality. It behaves like this. And remember, whatever you're doing hasn't been done before. That's why we're doing it. Otherwise, it's already been done, and why should we redo it? So the only answer that is correct is done, or I don't know. I can't tell. People get very, very upset when you say that, but if you want to be truthful, this is perhaps the only correct answer. You can't know, or you're done. So being a responsible developer doesn't mean that you're doing as you're told. That's just being obedient. That's obedience. Being a responsible developer means that you do what we know is right, even if people think differently. You might have to explain why you're doing stuff, and that could be a problem sometimes, because not everyone understands that stuff like waterfall doesn't really work well. But it works very well in theory, except if you read the original paper where the guy who wrote it says that this sounds like a good idea, but it will never work. But that part, a lot of people skip that part. This leads me to something that is called the Manifesto for Software Craftsmanship. How many in here has heard of it? A few of you, but not more. Okay, great. This is a manifesto where we, who at least want to be software craftsmen, say that it's not enough with only working software. We need well-crafted software as well. We need a reason to be proud of our job. And it's not enough to responding to change. We always want to add value. And we want to do it in steady pace, so we don't rush and deliver lots and then don't do anything. It's better to deliver small things, but often. And it's not enough with individuals and interactions. We want to build a community of professionals that actually are good at this and learn from each other. And it's not enough with customer collaboration. We want a productive partnership. We don't want customers that we work together. We want partners where we cooperate. So if you haven't heard about this one, look it up. If anyone wondered, there are no silver bullets. And I want to give you a few action points that you should bring with you from this session. On the 15th of November this year, that is a month and a few days, that's a Saturday, then there will be something called Global Day of Code Retreat. Attend that if you can. I have no idea if one is arranged or not in Krakow, but I know that the first code retreat I ever visited was here in Krakow. So I'm sure that there is one, or perhaps many. Attend that one. It's a day of practicing. Simple problem, but practicing. Practicing test-driven development, pair programming. If you haven't tried test-driven development, do it. You don't have to try it at work. Try it at home. It doesn't have to be something really fancy. Just try it and see that it seems to be working. Try pair programming. If you can't do that at work, I'm sure you have a friend who is a developer and might be interested. And if that doesn't work, well, drop me an email and I'll help you out. I'm doing pair programming regularly, remote, with a good friend of mine in Vienna. It works well. And last thing, try to get a GitHub account and share your pet project, or not try. It's easy to get a GitHub account. Share your pet project. I'm sure you have one. Why? Well, that's a way of advertising that you are a good developer. You write code that other people can understand, and you care, and you share. That's good thing. They are all good things. Once I was about to conduct an interview with someone that might be an employer, employee. He didn't show up. I found his GitHub account, and I realized that, no, we don't want to employ this guy anyway. So it was might as well been, he didn't show up, and that was good, because he shouldn't have the job anyway. So, I'm Thomas. I've been talking about responsible developer, and I'm sure that my time is out. Do we have time for questions or not?
Yes.
Yes. Do we have any questions? No. Yes. Oh, one over there.
At the beginning, you mentioned communication as one of the critical skills.
For one thing, communication. Yes.
Yeah, you mentioned communication as one of the critical skills for a responsible developer, and you didn't elaborate on this.
No, because it's very, very complicated. I'm not great at it, but I know that if you can't talk to someone and understand what they want, then you can't build it for them and deliver it to them. So you have to communicate in some sense. And what sense, in which way? There are other people who are a lot better than me on that one, but you have to communicate. Otherwise you can't understand what you should create for them. I mean, you would be guessing, and chances are that you wouldn't guess right.
Yeah.
So it's very important to know that, and if possible, practice it, but definitely be aware of that communication is very, very, very important. It's not okay to sit in your cubicle or whatever and not listen to music or something and never communicate. That's not an option. Okay. Any other questions? No?
Okay, can I have another one?
Yes, of course. There's probably a button there. Okay.
Okay, what should a responsible developer do when he meets irresponsible developer?
Do not get angry. Do not apply violence. That doesn't work. So that's a few things that you shouldn't do. The only thing that I think you can do that might work is, again, communication. Try to talk to the guys that you think is more or less irresponsible about things that is important. What could that be? That could be code quality. Discuss things, and you might find a shared view of the world. If you can't, that's one thing. Perhaps you should start a book circle. Read a book together. How many in here has read the Clean Code book by Robert C. Martin? A few of you. So the rest of you have a book tip. There's a great book called Clean Code that you want to read. It's great. Read it. I saw his keynote at the conference, and that got me started talking at conferences at all. I was very, very inspired, and that's from the Clean Code, that's where I started out with this, on this journey. So read that one.
Any other questions? Okay, so thank you very much for the lecture.
Thank you very much.